Hello, I'm Lloyd, S4's physicist, and in this video I'm going to be taking you through the Colourful Convection experiment that was in your science delivery box. So we are going to be looking at how the properties of a liquid change as the temperature of the liquid changes. So some questions to start you off. Maybe you've been in the bath before and you've realised or noticed that the hot water in the bath is closer to the top and the cold water in the bath is closer to the bottom. Same thing if you've ever been to the beach and been swimming. Maybe you notice that the further down in the sea you go, in the water you go, the colder it gets. So we are hopefully going to be looking into why that is in this experiment. So you'll need a few things to start you off for this experiment, which are in your science delivery box already. So first of all, you should have 2 plastic bottles like this. I've got 4 here, you may notice, because in this video I am going to compare what happens when you do both parts of the experiment at the same time. But probably for yours, you'll do both parts separately and then compare afterwards. You'll also need some food dye. So we have some yellow food colouring and some blue food colouring here as well. So your pots will look slightly smaller, slightly different to the ones I've got. You will then have some wooden stirrers to help you stir the dye into the water. And also some playing cards. Now those are just, well, you'll see later, but they're just to keep the water separated before we're ready and keep them in their bottles. I've also, in my experiment, got a tray here. If you don't have a tray, don't worry, you could also do it in the sink, or you don't have to do it in the tray or the sink at all, but I would recommend it because it does help manage the mess that could happen. So what you'll want to do is to fill one of your bottles with cold water and fill it all the way to the very top, right to the rim there. And as well as your cold water, you're also going to want warm water in the other bottle, again filling it all the way to the very top. Now it's very important that you don't use water that is too hot for you, so it shouldn't hurt you, for example. So don't use boiling water fresh from a kettle, use hot water from a tap. So I've actually got my hot water in this flask. Okay, so I've got my hot water and my cold water. What we want to do now is put our food colouring into the water. So I am going to put the blue food colouring in my hot water and the yellow food colouring in my cold water, but it doesn't really matter which way around you do it. So what we want is enough food dye just to make sure that the whole water changes colour. So I'm going to give that a little stir. So you shouldn't need too much. There we go. Put yellow in that one. I'm going to do the same again, so I'm going to put my blue food dye in that hot water, my yellow food dye in the cold water. So we're just about ready to go. So what I'm going to do is flip these bottles over, so I'm going to put one on top of the other. This is a bit you need to be quite careful of, especially if the water is a bit warm, and this is why I recommend a tray or a sink to try and keep the mess under control. And this is also why I've given you some playing cards, so you can keep the water firmly in the bottle for now until you're ready to take it away. So what I'm going to do, first of all, is put the cold water on top of the warm water. So I'm going to put the playing card firmly down here and hope it doesn't all leak out straight away. So I'm going to turn this upside down. Very carefully pop it on top there. As you can see, I'm already starting to make some mess. Now, you might want someone to help you out with this, which is absolutely fine. Maybe you want someone to hold the bottles for you. And then you very slowly take the card away until they're on top of each other there. So I've put the hot water on the bottom and the cold water on the top. And as you can see, it's already starting to mix colour actually. So when you mix blue and yellow, you get green. And whilst we're waiting for that one to mix, I am going to do the same thing with the other one, except I'm going to put the hot water on the top and the cold water on the bottom. See if I can make even more mess. Ah. Oh, there we are. So if you do this, definitely try and keep it in the plastic bottles rather than using glasses instead, just because there's a risk of it falling off and shattering. But look what's happened. So on the one on the left, we have put the hot water on the bottom and the cold water on the top. And then on the one on the right, we have put the hot water on the top and the cold water on the bottom, and you can straight away see the difference. So the reason that the water in this part mixed and the water here did not and stayed in layers is all because of the density of the water. And the density of the water drives something called convection of a fluid. And by fluids, I mean liquids or gases. And convection is a way of moving heat from one place to another in a liquid or a gas. Density of a fluid, like water, for example, is a measure of how close together the particles in the fluid are. So if we were to look at the molecules that make up water, so these are H2O molecules. So water is made of H2O, which means we've got 2 hydrogens and we've got 1 oxygen. And these molecules are floating around quite loosely because it's a liquid. Now when we heat something up, so for example I had hot water, we give the molecules energy. So when we give these molecules energy, they tend to move around a lot more. And when they move around a lot more, they tend to separate away from each other, and the gaps between them become bigger. It's a bit like if you and your friends all held hands in a circle, then jumped up around and tried to move, you wouldn't be able to keep holding hands because you've got too much energy and you would eventually let go. Same or very similar sort of thing with the water molecules. They've got more energy and they move away. And as they move away from each other, they become less dense. And if they were closer together, they would become more dense. So when the hot water molecules are further away from each other because they're less dense, there are more gaps for cold water to move through. And because cold water is more dense, it will move through the gaps and tend to sink, which is why in our bathtub example we mentioned right at the beginning, the cold water in your bath tends to stay at the bottom and the hot water will rise to the top. And this is also the same process that drives the heating in your home. So for example, a radiator, that will heat the air molecules and the hotter air will tend to rise and the colder air will tend to fall because of the density difference in the molecules. So that has driven our lovely colourful effect here. So our hot water at the bottom has risen because it's less dense. The cold water has fallen or sank because it is more dense, and they have mixed as they go, giving us this green colour. Whereas when we had the hot water at the top, it is more dense than the cold water at the bottom, so they tend to already stay in their layers, which gives us this lovely colourful effect. Now I think you could take this further if you wanted to. Try changing the temperature of the water, so not only changing hot and cold, but see if you can use the thermometer we've given you in your delivery box to measure the temperature and see whether the bigger the temperature difference or the smaller the temperature difference changes the speed of the mixing. So that's all from me in this video. Let us know how you get on in your experiments. See you again soon. Bye.